In passive sensors, we have 4 examples that are stated here: the Landsat, the Aster, the QuickBird, and Iconos. All these are categorized under passive sensors because they cannot really function effectively if there is no sun rays that are being illuminated on the objects on the surface of the Earth and it's being reflected through the atmosphere back to the camera of the sensor or the camera of the satellite that is in space. So these, I don't know, has anyone ever used a Landsat imagery here before? Someone said he has used it, but we can just easily categorize all these as thermal remote sensing. Thermal remote sensing. Then the radar remote sensing, which is the active one, are LiDAR and radar. LiDAR means light detection and ranging, while radar means radio detection and ranging. These ones are much more powerful. They work without the help of sunlight. Whether at night, whether during the day, they are working. And their spectral resolution is quite different from the passive sensors. I know I am saying a lot of things. Yeah, I decided to summarize the class even before I started. So whatever it is that I've said in the first 2-3 minutes of the class, they are very important. Every other thing is just technical jargons, things that we would see it in the library to read and read and read. All we need to know is there's one very important thing that we tell people at Geoinfotech. When we are meeting someone for the very first time, and the person is bringing job for us, maybe there's an analysis for us to carry out, we always want to know the reason for which you are consulting us. Once we're able to know the reason, okay, you need to make a map of so-so place for so-so purpose, and that is all. We will know the choice of the data sets to use. So all this, once you know the reason for which a client is consulting you that they need to carry out an analysis, then you as a professional will be the one to determine which choice of data sets are you going to make for them. So LiDAR, light detection and ranging, and radar, which is radio detection and ranging. So from here, I would want us to quickly move as well. Let's move ahead. My slide is not moving. Next slide. Okay. So what are the platforms that are available in remote sensing without having to make physical contact with the objects we are mapping? These are the 4 platforms that are available. We have the spaceborne, we have the airborne, we can go drone-based, and we can be ground-based. I'll start from 4 because I think 4 is much more closer to us. Every one of us, we are on the surface of the Earth, we are on the ground. Before the advent of remote sensing, before technology brought remote sensing close to us, there is a field that we call photogrammetry. I don't know if anyone knows what photogrammetry is. Photogrammetry, the art and science of taking images, pictures, using our camera and trying to analyze it, photogrammetry. So as technology improves, technology as it grows, that's when we now have remote sensing. So from photogrammetry, I could say this ground-based platform or process is purely photogrammetry. When you have to stand on maybe a mountain or you climb a tall building, then you station your camera, tilt it some way, then you take imagery, then put it on your on your system, then try and analyze it using your software. That is photogrammetry. So it is ground-based. You are standing on the ground, you are taking pictures or images of the surface of the earth or a phenomenon that you want to map. Then we'll move up a bit. Drone based. This drone based, some years, like let's say some like years like 30 years ago, we used to see aircraft flying everywhere. You see cameraman trying to station their camera, trying to take images of the surface of the earth. But as the invention of drone come, there has been like a reduction in the use of camera because of the cost. It is not cost effective anymore. When you have a drone, the risk you are taking, no one has to fly an aircraft. So all you need to do, the risk you are taking is just your drone that is flying. No one gets to die, even if it's going to crash. So there is introduction of drone, and the drone can go as far as 150 meters up, 200 meters up to carry out data acquisition. So we have ground-based, we have drone-based, and we'll move up a bit, we have airborne. Airborne, it can have some aircraft that can fly as high as 300 meters up, 400 meters up above the earth, just to take images of the surface of the earth. Airborne. Then we have spaceborne. This spaceborne is strictly satellites that are orbiting in space. When we talk about spaceborne, we talk about geodesy, and we talk about geodetic engineering. The principles that are put together to launch satellites in space, how they acquire data, the necessary corrections that will be done in order to, when we are processing and analyzing our data, then subsequently get our results. So these are the platforms that are available in remote sensing. Then introduction, drone introduction. So I think I would be pausing here for now, while my colleague will take over again with the drone aspect. When he's done, I'll take over back. Thank you for listening so far. So do we have, okay, if you have questions, please always jot them down.
Okay, so if you have any question, please just jot them down. Because of our time, we'll not be taking those questions now. All right, so in this section, we'll be talking about what drone is all about. So from the previous slide, we noticed that drone is one of the platforms for remote sensing. So we can classify a drone as a tool for remote sensing. You understand? Now we all understand what remote sensing is all about. Then we are narrowing it down to one of the most recent and common hardware we are using for remote sensing as of now. So drone generally is more formally known as unmanned aerial vehicle. Most professionals, they call it unmanned aerial vehicle. Some people will call it as unmanned aerial vehicle system. It encompasses everything that is needed to carry out that project. You have your drone, you have your station, you have your monitor, everything is a system. So it's considered as a flying robot. Okay, you can call it as a flying robot that can be controlled without you physically being inside that object. Okay, so it can be controlled remotely. That's why it's termed as a drone. So if you see a device flying and you see someone inside, it's no more a drone. The drone it must be controlled remotely to be classified as a drone. All right. So and understanding what drone means for surveying is different from a drone for just photography and videography. We have a drone for geologists, for those that are into geology. And we have drones that are specifically built for mining, and those that are into oil and gas. You have some drones that can detect oil leakage based on the amount of heat coming out from that surrounding. You can understand where it's coming. So for every purpose you are trying to use the drone for, you have to know the type of drone to get. So in a nutshell, we'll be doing a bit of demonstration on what how drone works. Okay, so in this point, I won't be sharing my slides. We'll be on the video live there. So we have two commercial drones here. Some of us, we are familiar with this type of drone. It's called the Phantom. DJI Phantom. This is the Phantom Advance. It's younger than this one. This one is older. Okay. This one has sensor both in front, in the side, the back, beneath it, and we'll be explaining all of that for us. And you can see that this drone also has its own remote control. You can have two remote control, but they can't be used for any of them. It can only be used for the assigned drone itself. Okay. So we'll be doing a bit of test run, but I just want to wrap up and give a summary of the different types of drones we have available. Then we have another one that is this one is enterprise drone. Okay, this one is an enterprise drone. The reason why it's called enterprise because of its capability compared to the commercial drone. It doesn't mean that this commercial drone cannot still do the work for surveying. Okay, and understanding the aim of any project you want to venture into, we give you further idea on the type of drone specification you'll be going for. So if you are going into a project for like photography, videography, you can just get a drone that just has a very good resolution for its camera. If you are going into a surveying and mapping, you can go with a drone that has inbuilt GPS or has GNSS, drone with RTK. You understand? If you are going into a project that has to do with, okay, there was a project with this one time ago. We had to inspect some solar panels. They had to study the solar panel to understand where or the health of the solar panel in order to further manage that solar panel for that Gabe Lake Mall. Okay, so you can use drone to know where there are possible effects on the solar panel based on the emission of heat it gives. All right, so you have to get a drone with infrared. Do you understand? So, like I said, let me just do a recap. If you want to do a survey, you have to get a drone with RTK. If you want to do just photography, videography, you have to get a drone with just high resolution pixel. And don't, for the fact that you are going into survey, doesn't mean you will not take cognizance of other parameters or factors like the camera resolution and the inbuilt GPS and the life expectancy, the long range duration for the drone. Okay, so I'll be giving a preview for this drone. Okay, for this drone, it's called the DJI Matrix 210. There are other versions, Matrix 200. They call them the Matrix 200 series. We have the 210, we have the 200. Then we have the Matrix 300 series. Okay, these are the Phantom series. All right, so I'll just give an example of how we operate this drone. It has its own controller and it came with its own monitor. And this is one of its battery, and we also have another battery here. It works with both of them together, and we have the phone holder in case you are not making use of this. You want to use your phone, you can make use of your own personal phone. And okay, that's all for now. So if I'm going to be launching this drone, one of the things I'll take note of is the basic functions of this drone. Understanding the function of the drone gives you more idea on how the drone operates. Okay, there are some drones that you have to on the controller first before you on the drone itself, and there are some drones that you have to calibrate. Most drones that are related to surveying, you have to calibrate them for best of efficiency. So we have this battery here. Okay, the two batteries goes into the drone at the back while it's here like this. I hope you can all see it. Okay, and to know the percentage of the battery, just click on this. So because of our time, I won't be doing too much detail about this drone, so I'll just rush into how we launch the drone so you see the demonstration of what I'm doing. Okay, you saw the way I slot the both of them inside, and knowing the battery of both of them, just click on it once. But if you want to power on this drone for children's safety, you don't just press it down like that. You have to press it down for 1 second, you wait and press and hold, then you powered it on like that. All right, so the next thing again is there's something we call the blades. The drone can't fly without those blades. Another thing, they call it the propellers. Okay, the drone can't fly without the propellers, and the drone itself is is smart enough. It communicates with the pilots by giving signals from here. All these functions, some of them are also available within the commercial drones. The commercial drone has its own signal down here. It also has its own sensor here. You will see the similarities between this one and this. This one has its own sensor here, and it has its own sensor here, and it has the sensor in front. Okay, so and this is its monitor. So just slot the monitor with the controller. The monitor will enable us to see whatever the drone is seeing. And understanding the spec of this drone gives you an idea of its range. There are some drones that can go as long as 7 kilometers, but that is if you are flying automatically. And there are some drones that can go as long as 1 kilometer. That's if you are flying it manually. You understand? So a lot of people make mistakes of that. They try because they see online, they'll write 9 kilometer, 10 kilometer, then they will try and fly their drone manually to reach that 9 kilometer. And at the long run, you will see that the battery is 20%. The 20% cannot take it and come back. So, so most time in cases like that, the drone won't come back. It will just land wherever it is down like that, if it understands the critical level. So, and again, the reason why it's commercial is because they've added so much functionality for this drone safety. Once it's reached a critical level, it gives a warning sign. It acts in a way that it has to come back. If it reaches a low battery level, it gives a sign and it acts in a way of warning you to come back home. But if you not come back home and it reaches the critical level stage, it will come back home without taking permission from the controller. All right, that's for this drone, and the same with the commercial drones. All right, so for the drone, it comes with its own spec of camera. Okay, it comes with its own spec of camera. I'm just going to rush this so that you can see that the commercial drone has its own camera inbuilt. So you can choose the spec of camera you want. You want the one with just optical, like my colleague has explained what remote sensing is. You've seen the different types of sensor we have for remote sensing. So for this type of drone, it comes with its own type of sensor. So you can choose to buy the one with just RGB camera. You can choose to buy the one with RGB with infrared. You can choose the one with LiDAR. And you can choose other spec, multispectral kind of camera. All right, so you just have to slot this camera in front of the drone here. While it is attached to the drone, it automatically calibrates itself, okay, with a gimbal. So understanding what gimbal means is different from what the camera is itself. The gimbal helps to make stability. Even if the drone is going up and down, you see that the stability is there. The camera is not following the direction at which the drone is going. All right. So, and another advantage about this drone is that you can rotate the camera in another direction while rotating the drone itself in another direction. I'm going to on the controller, the remote control. Automatically, it will power on the controller as well. Okay, and understanding this, the next thing is to fly drone, you must know the power source and have a power source, and such as battery or fuel. There are some drones that works with fuel, okay, while some works with battery. I've seen, I don't know if it is true, but I saw it online. You see, with a drone with they call it what is this stuff they put on you? Solar, yes. The drone will attach with solar. So it's, as the drone is on the air, it's charging itself and it increases the life expectancy. Okay, so let me just let me see if I can put the blade. So we just have a few. We're not flying it inside here, just for, but we'll try powering it on to have a survey. Black or black. So for this blade, it rotates in different direction. We have a body with the ash color. We have the one with the black color. So when putting the blade inside it, attaching it with the drone rotor, they call this a rotor. All right. When attaching the propellers with the rotor, you must know which one is white and which one is black. Some is silver, some is black. Okay. So I'm going to be attaching the black with this. It goes, I think, clockwise, anti-clockwise, sorry, to lock inside, and this other one goes clockwise to lock inside. Yes, thanks for this one. Mm. Yeah. One advantage about this drone is it can carry more weight compared to this one. So you can attach more sensor to this drone. You see that it gives you another space for attaching another type of camera here. So as the drone is like that, I can rotate it up and down, and I can rotate it 360 in different direction. Okay, while the drone is still maintaining its own focus. So I'm going to display my screen while I'm on the phone here. So we have the, okay, I'll go to manual flight, and you see whatever the drone is seeing, which is us. To be seeing every one of us. Um, okay, sorry. There's a small protector in front of the camera, so what is, the drone is seeing is definitely seeing everybody. So one beauty part about this drone is that whatever you're doing with the drone can be projected here, and whatever this is projected can also be shared with HDMI to another different screen. With a different screen, you can distribute it to other different boardrooms. You understand? So that's like you are flying real time. You understand? So flying real time, you can take observation of different factors and different areas. You can use it for security. You can use it for monitoring. You can use it for project monitoring, and you can use it for mapping and survey. Okay. So I'm going to power on the drone. Understanding the condition of the drone is the most important thing before you power on the drone. You can see that the drone is blinking green only, and on this place it's telling us ready to go. So you don't just fly your drone without you communicating with the drone itself. All right. So the next thing the next thing we have here is they also have rotors and propellers. We've talked about that. The frame of the drone is typically made of lightweight composite material. So if you move closer to the drone, you will notice the fiber objects around the drone. The reason why they suggested fiber is lighter, and it's stronger. You understand? And drones require a controller. You have to get a controller before you can operate the drone. So bringing these controllers together makes me to be able to power on the drone. All right. Now there is a sound. The drone is blinking. Okay. It's having a sound. It's telling us that the drone is closer to an object. If I should lift up the drone now, which I'm not going to. If I should lift up the drone now, move it back, the sound is going to stop. So that sound is, they call it vision sensor. It observes objects 7 meters away from it, and it stops automatically by itself. It doesn't move closer to that object if the sensor is turned on from the settings. You understand? So that's just all for now. I'm going to power up the drone. Okay, so and again, the next thing we'll be looking at here is different sensors and characteristics. So I'll be inviting my colleague to just talk a bit about that. Um, okay, I'll be inviting Mr. Surveyor Yinka to talk a bit about that. We're having different sensors and what they are. You can see different raster with different bits and bands. Exactly. You can transfer it back to.
Sensor platform characteristics. These are technical jargons. These are English. But I would see if let's see how we can explain all this. Spectral resolution, radiometric resolution, spatial resolution, and revisit time, which is the temporal resolution. The temporal resolution simply can simply be explained as the kind of resolution that one will get over time. In 2019, you downloaded a Landsat imagery of a particular area. The same 2019, maybe you downloaded for January, then in March, you downloaded another one. Then third quarter and fourth quarter of the year, you downloaded like 4 images like that. These were downloaded over time, and you can check for the resolution that are in between, like all these images that I have downloaded. That is how I would explain what revisit time or temporal resolution as. Then spatial resolution, the smallest unit that a satellite in space, the smallest unit or smallest object that satellite in space can cover. For QuickBird, I think it's 0.6 centimeter or 0.6 meter. That a QuickBird or Iconos, I don't know, I can't really recollect. Is it QuickBird or Iconos now? 0.6 meter resolution. So an object that at a time a pixel we detect is what we explain as spatial resolution. While radiometric resolution, when satellites are in space, they come across some evil forces, atmospheric forces that are trying to pull the satellite, which I could say is perturbations. They fight against all odds to make sure they keep orbiting. Those perturbations bring about errors on the satellites that are orbiting in space. Then that is where we talk about how, when we're able to like carry out corrections for radiometric resolution, then that is when we have a much more LD results without having to bother about radiometric error. Then spectral resolution, part of the electromagnetic spectrum that is measured. So when we look at this now, you see from this very image, we have Landsat 5, we have Spot, we have Landsat 7, and we can see the resolution in meters. How to simply just understand this is when an object is in space and you are taking, you are capturing a particular phenomenon. What is the smallest size of the object that can be detected? That is what we talk about, resolution. So that about sensor platform and the characteristics which they carry. Then remotely sensed data can also be captured as area camera, as multispectral satellite, as a radar satellite, and as hyperspectral sensor. Area camera, we all know what area is, camera. Just when you fly a drone or you stand on top of a very tall building and you capture an area, that simply becomes an area satellite or area camera rather, which we call in drone technology, we call it auto mosaic or auto photo.